next tool that we'll look at is sendmessage. Sending messages will usually be done programmatically in practice, since normally you want to send messages based on other messages read on the bus. But in case you just want to do a quick test to determine, for instance, if a gateway is properly denying specific messages through, or an ECU is properly validating input on an incoming request, you could use this tool. The port and CAN baud are the same as read messages. PGN is the parameter group number of your message between 0 and 65535, or FFFF. The example I have here is one that we are looking at in decoded form a moment ago, so I'd like to resend this onto the bus in order to modify the data. The PGN in this case is hex F001, as we saw before. The data is the actual data portion of the message in hex string format. This is not limited in size to 8 bytes, as TruckDevil will automatically handle the transport protocol to segment and send out the necessary additional CAN packets for you. In this case, this is the hex string from the original message that we saw in decoded form. Optional arguments include priority, where the highest is priority 0, lowest is 7. Source and destination addresses can be specified with TAC A and B. The source address can be between 0 and FF, or 255. The destination address that you specify may or may not have an effect, depending on the PGN that you specified. If the PGN is in the broadcast range, the destination address will be ignored. In this case, we have specified the source address as hex 0B, because our sending node is the brake controller that has this address. Lastly, TAC-V can be used to print the messages you sent, and TAC-VV can be used to print the decoded form of the message that you are sending. So let's go ahead and send this message, and then we can add the TAC-V and TAC-VV flags to see how it affects it. As you can see, when you do not specify anything, it will not print anything. Specifying V will simply print the message that you sent. VV will print out the decoded form of the message. Now we can try modifying the priority TAC-P flag using TAC-V to see the message that we sent. We could bump up our priority to 0 to attempt certain flooding attacks. As you remember, the original priority was 6. Let's change that to 0. As you can see, it changed the priority. Lastly, we could modify the data portion of the message to see how it changes in the response. As you can see, the last byte there was changed.